Okay, so real talk. Last week I spent 3 hours convincing myself that a Chinese AI lab had just built the most capable coding model on the planet. I had the benchmark open, I had the GitHub tab pinned, and then I actually read the footnote. One footnote, buried under a table. And that footnote changed everything I thought I knew about how AI benchmarks work, and honestly, it made me feel a little embarrassed about how I'd been reading leaderboards for the past 2 years. So today, we're talking about DeepSeek Harness. What it actually is, why it matters more than the model score everyone's been arguing about, and why there's a decent chance you've been misled by every benchmark table you've ever seen, including ones I've probably talked about on this channel. Let's get into it. First, what even is a harness? Because I genuinely did not have a clean answer to this question before I went down this rabbit hole. I thought it was basically just a wrapper, a thin shell around the model. I was wrong, and the degree to which I was wrong is kind of funny. Here's the right way to think about it. Imagine a student sitting an exam. The model is the student, but the harness is the room the student sits in. And it turns out the room matters enormously. One room gives the student 3 hours, an open textbook, and a machine that checks their arithmetic as they go. Another room gives 40 minutes, a bare desk, and 2 pens. You would never print those two results side by side and call it a comparison of students. But that's exactly what every AI benchmark table does. Every score you've read in the last 2 years is actually a pair, a model, and the room it was tested in. And the industry almost always only publishes one half of the pair. That was a bit of a gut punch when I properly understood it, because I've made videos about benchmark tables, I've talked about score comparisons, and I was treating them like clean, neutral measurements when they were anything but. So when DeepSeek published a score of 87.9 on Terminal Bench for their coding model enough to top the public leaderboard, and then in a tiny footnote mentioned it was produced using something called minimal mode of DeepSeek Harness, most people saw the number and celebrated. A few people saw the footnote and went, hang on. I am proud to say I was not immediately in that second group. But I got there, eventually. 90 minutes after that model card dropped, DeepSeek shipped the harness itself. And it hit 170,000 GitHub stars within a week, which, if you're not a developer, just know that's people losing their minds territory. But here's the thing that actually broke my brain. The public Terminal Bench leaderboard at tbench AI does something almost no other benchmark does. It lets different people submit the same model weights inside different harnesses, which means you can literally read the wrapper's contribution off the page. Here's the example that stopped me mid-scroll. Gemini 3 Pro, running inside a research harness called Terminus 2, scores 73.9. The same Gemini 3 Pro, exact same weights, running inside Google's own Gemini CLI tool, scores 65.8. That's 8.1 points. The gap is the wrapper. And the wild part? The vendor's own tool is the one that loses. Now here's where it gets almost philosophical. If you hold the harness constant and just change the model from Gemini 3 Pro to Gemini 3.1 Pro, the score moves from 65.8 to 65.8. A whole model generation. Billions of dollars of training compute. And it contributes nothing because the room stayed the same bad room. I kept checking if I was reading the table wrong. I wasn't. This holds across the board. Fable 5 scores 83.8 under Claude Code and 80.4 under a different harness. GPT 5.5 scores 83.1 under Codex CLI and 78.0 under something else, 5 points for the wrapper. In 4 out of 5 pairs on that leaderboard, the software with no model weights in it at all is worth more than a year of model development underneath it. So when DeepSeek says their model scores 87.9, there's an important follow-up question. Compared to what? And using whose room? Here's the uncomfortable answer. There is no DeepSeek row on the public terminal bench board. Not the model, not the harness, nothing independently submitted. So the number everyone's been holding up against Claude Code's 83.8 is the lab's own run versus an audited public submission. Those are not the same measurement. Even inside DeepSeek's own document, a competitor called Kimi K3 beats them 88.3 on terminal bench to DeepSeek's 87.9. DeepSeek printed the numbers that beat them, which is genuinely more honest than most labs. But 2 of the 10 rows they published are marked as internal test sets nobody outside the building can reproduce. So here's where I want to give DeepSeek real credit, because there's a part of this harness that is genuinely clever engineering, and I don't want it to get lost in the benchmark drama. Inside the repo, there's a design note dated the 5th of July, and it has one rule. Once something has been sent to the model, you never go back and change it. That sounds simple. It is not simple to actually build. A typical AI agent session is basically a list of messages that can get shuffled, edited, summarized, and those edits can silently corrupt the context the model is working with. What DeepSeek built instead is an append-only log. Every event gets added to the end. Never modified, the message history sent to the model is rebuilt fresh every single turn by running through that log from the top. No mutable array sitting around waiting to be accidentally corrupted. The derived history is frozen, so if a plugin tries to reach back and edit it, it throws an error instead of quietly breaking things. This might sound like architecture pedantry, and the first time I read it, I kind of skimmed it. But then I understood why they did it, and it clicked. Prefix caching. If you're paying for AI API calls, you probably know that cache hits are cheap and cache misses are expensive. At the time this note was written, on DeepSeek's own platform, the gap between a cache hit and a cache miss was 120 times the price. That's not a rounding error. And prefix caching only works if the prefix, the stuff at the start of your message, is byte for byte identical every time. If anything shifts, the cache misses. So if you're running a long agentic session and your message history keeps getting mutated and reshuffled, you're bleeding money on cache misses the whole time. Their solution to the summarizer problem is the detail I keep thinking about. When they built the tool that summarizes old context to save space, the first version put "you are a summarizer" at the front of the request, which sounds totally fine. Except that invalidates the entire cached prefix at the exact moment your history is longest. So they move the instruction to the back. They replay the previous request word for word, then append one new message at the end. They even kept the tool definitions that the summarizer can never use because deleting them would shift every token that follows out of alignment with the cached copy. Their actual words, the rule is not send the model what it needs. The rule is do not disturb the bytes that came before. I read that and had a moment of genuine respect. And it works. One tester put a satellite tracking task through it, 35 minutes, 2 turns, 20 million tokens, 100% cache hit rate. Another ran the same prompt through DeepSeek Harness and Claude Code side by side. DeepSeek Harness finished in 11 minutes, used 483,000 tokens, cost 5 cents. Claude Code with Opus 5 was still running at 30 minutes, had used 48,000 tokens, and the human judging the outputs said Claude's result was the more professional one. So that's 10 times the tokens, a 20th of the cost, 3 times the speed, and a worse output. That's a completely new shape of trade-off, and I don't think anyone has a good framework for scoring it yet. Finished fast and cheaply, but the answer was worse, is not the same as better model or worse model. It's something else, and we don't have a box for it yet. All right, buckle in, because this is where the whole thing gets genuinely strange. Inside the DeepSeek Harness repo, there's a directory called subagent, and 2 of the backends inside it are called subagent Claude Code and subagent codex. I assumed when I first saw this that they were like re-implementations, inspired by versions. Nope. The first one pins Anthropic's official Claude Agent SDK at version 0.3, which bundles Claude Code 2.1 itself, a 256 megabyte payload when unpacked. It has a permission mode that defaults to not asking for confirmation, and an option literally named bypass permissions. The second one starts OpenAI's official codex wrapper as an app server over stdio. So a Chinese AI lab has shipped a harness that internally wraps Anthropic's and OpenAI's own CLI tools. And every one of those plugin readmes documents its own token effect and its own KV cache effect, which is a level of housekeeping I genuinely haven't seen from anyone selling agentic tooling. And then the repo ships a claude.md file and a .claude skills symlink. Meaning DeepSeek's harness repo is configured for Claude Code to work inside it. One developer claimed at least 20% of the commits came from codex work trees, though that's a single tweet, so take it as a claim rather than a confirmed fact. But the shape of it is real. DeepSeek built a harness that beats Claude Code on a benchmark, using Claude Code and codex internally to help build it, and then ships those same tools inside the harness for you to use. I don't know what to call that. Recursive? Audacious? I've settled on extremely online. Here's the part that made me actually nervous. There's a file in the repo called thirdpartynotices.md. Most people don't open these. I didn't open it the first time I cloned the repo. When someone flagged it, I went back and read it, and it states that the project owner authorizes distribution of every version of the official Claude Code CLI and platform payloads, and then adds that this identity scoped authorization does not classify their declared terms as permissive. Read that twice. An MIT licensed harness from a Chinese lab is redistributing Anthropic's command line tool while stating in writing that Anthropic's license is not a permissive one. And the Anthropic's Claude Code repository, for its part, declares no license at all through the GitHub API. I am not a lawyer. I cannot tell you what this means legally. But it made me uncomfortable, and I think you should know about it before you build a production workflow on top of this thing. There's also a security concern documented in their own README, which earns some credit for honesty, even though the thing being disclosed is alarming. There is no isolation between plugins. Every plugin gets full shell and file system access. Plugins are found and installed from GitHub, and Creator Mode gives the model a tool that runs arbitrary JavaScript against the live runtime. Their own documentation says to treat that as shell access. One bad plugin in your config can reach your API keys. The harness's job, in theory, is to make prompt injection attacks harder, but this plugin architecture makes it easier. That's not a criticism I'm inventing, it's in their own docs. The repo's issues tab is switched off. Not zero open bugs. Nowhere to file one. Claude Code has 14,785 open. DeepSeek Harness has a closed issues tab and a version number of 0.1. Now, the part I genuinely respect, and I want to be clear, this is earned. DeepSeek named the room in a footnote and then shipped the room. Alibaba, XAI, and others all published benchmark tables the same week, all self-run, all choosing their own comparison columns, and not one of them gave you the harness. Publishing the harness doesn't make the claim true. It makes it checkable. That's a real difference, and nobody else offered it. On top of that, 728 design notes in the repo are public, everyone required to have an alternatives considered section. And there are 4 written postmortems, including one where their own agent edited the web UI it was running inside, accidentally started a second dev server, checked that one instead of the original, declared success, and left the user's actual page blank. Then started a third server. That's the kind of failure story companies usually delete. They published it. That matters. There's also a price update that shipped alongside the harness that almost nobody covered. The cache hit input price on V4 Pro went up roughly 12-fold the same afternoon. The cache discount shrank from 120x down to 30x. Peak pricing hours are Chinese business hours. The free harness and the dramatically more expensive cache pricing shipped 90 minutes apart. And the column that got most expensive is exactly the column agentic workloads live in because agents replay the same prefix constantly. The free thing and the expensive thing arrived together. Worth knowing. Here's my practical take after spending way too long in this repo and way too much time rereading that benchmark leaderboard. Don't wire production automation to a release candidate with no issues tab. That's just not a place to put anything you care about. But do run minimal mode against a real task you actually have, because for the first time, you can check a vendor's agentic benchmark score with the vendor's own rig. That's genuinely new. If you install both the Claude Code and Codex subagent bundles, you're adding about 250 megabytes of your competitor's tooling to your system. Not a big deal, but know it's there. And whatever you use, go read that design note about the append-only log. The discipline in it is free, it applies to anything you build on, any model, and it's probably the most transferable idea in the whole repo. The one signal I'm actually watching? A DeepSeek row appearing on the public terminal bench leaderboard, submitted by someone who doesn't work at DeepSeek. That's the single event that turns 87.9 from a claim into a measurement. Until that happens, the gap between 87.9 and 83.8 tells you less than the 8.1 point gap between 2 runs of the exact same model weights in different rooms. Because every score you read is still a model in a room. Every lab sells you the model. DeepSeek is the first one that actually handed over the room. And a benchmark you can't rerun was never a measurement. It was an advert with a decimal point. If any of this messed with how you think about AI benchmarks, good. Drop a comment. I want to know what you're going to reevaluate. See you next time.